Welcome to qnawire.
Welcome to the problem number 31.34. So in this question we are given that when you are off to Europe, so the output electrical voltage from the sockets is not 120, rather it's 240. So we have the power which is from the dryer outputs, which is equals to 1600 watt at 120 volt. So we need to find out how can we operate this dryer via the 240 volt line in Europe. So definitely we have a device, and this device is called as a transformer. So this transformer changes from V1 to V2 voltage, having N1 turns to the N2 turns, and we have I1 current passing through the wire with V1 voltage, and that changes to I2 with corresponding V2 voltage. And we are given here the voltages here and power average, and power average is conserved over both condition. I mean, we have this situation and this situation, so power is conserved because the energy per second is conserved. And we have a transformer that converts the voltage V1 to V2 or V2 to V1, and this formula is the condition that is given by the geometry of the transformer. So we have this situation here. So we have the resistance. If we talk about the resistance, so we have P average equals to Vrms square over R. So all these values are RMS voltages values. So looking at this one, so we have V1 I1 equals to V2 I2, whatever the power average was before transforming or changing the voltages. We have this situation. So looking at this formula here, so this gives us R effective, which is the new resistance, equals to R over N2 over N1 square. So we have V1 this voltage, V2 this voltage. So we have N2 over N1 equals to 1 over 2. So this is our A part. So we will use step down transformer, because we are getting the 240 voltage, but we want 120 voltage. So we want to convert this voltage to the 120 because our instrument can handle only 120 voltages. So we have to use the step down transformer. So we have this much. Now this was our part A. Now we go to the part B now. So we have this situation now. This therefore this I1 gives us P average over V1, which is equal to 1600 watt over 240. So the current is 6.67 ampere. Now we have this one current. So now we have the resistance. So we have resistance equals to V2 square over P average, which is equals to 120 volt square over 1600 watt. So this is equals to 9 ohm. So now the effective resistance of the blower has changed, so which is equals to R effective, which is R over N2 over N1 square. So this gives us 36 ohm. So the question for that's the answer for our question. Thank you for watching the video.